What James Webb saw at the edge of the universe kept the scientists shocked. You guys already know that James Webb Telescope can take pictures of star clusters and galaxies far away. But have you heard that James Webb Telescope has seen something amazing at the edge of the universe? If you are wondering what exactly James Webb has found, then it's time we delve deeper into the beautiful world of astronomy. So, let's get started. Hello everyone, and welcome back to our YouTube channel. Please make sure to subscribe and turn on the notification bell so you can catch all of our new and amazing videos. In the first moment after the Big Bang, our world was a sauce of particles that was so warm and dense that it was nearly impossible to imagine. Over the following 3 minutes, as the universe grew and cooled, the nuclei of helium and other extremely light elements started to appear. After 400,000 years, it was cool enough in the world for the initial atoms to form. When the universe was about 100 million years old, circumstances were suitable for the initial stars to form. These huge fireballs have mostly been made of hydrogen and helium and had unique characteristics from stars today because heavier elements did not yet infect them. All first suns were bigger and brighter than the stars we see presently. They came together to form proto-galaxies, groups of gas stuck to huge, visible scaffolds of dark matter. Gravity controlled how these early galaxies interacted with each other. Ultimately, they combined to make bigger galaxies. Chaos describes how the early universe came to be. It is assumed that the universe took a billion years to become the more organized place it is currently. When we look at any of these older galaxies, they appear very distinct from the closer and most recent galaxies. The nearer an entity is, the more its light shifts towards blue. The further away an object is, the more light it shifts towards red. Let me explain. As brightness from a very far away galaxy travels through the cosmic void, it is extended by the universe's expansion. This widening of wavelength is called redshift. The greater the redshift value is, the greater the light has been stretched. So, the farther away the galaxy is. That means the first galaxies must be redshifted and have a considerable redshift significance. We couldn't view them until the James Webb Space Telescope was put into space. What do you know? Again, it has to do with what we know about the universe. Now, because we have a powerful lens aimed at the deepest part of the universe, our idea of what is surprising in astronomy pictures has changed a little. It's hardly a surprise anymore when NASA's James Webb Space Telescope finds another beautiful old part of the universe. At this spot, we know that the bold new machine never disappoints. But it's getting tough to keep up with the telescope because it's changing how we think about how galaxies form and change. And it just broke the record for the oldest galaxy. Several of these initial galaxies may challenge what we know about how galaxies and their dust change over time. Webb found galaxies that are very vibrant, rich in the middle, and big. One of them is called Glass Z13, and it was created only 300 million years ago after the Big Bang. This makes it older than any other galaxy we have seen before. We know that all these galaxies are so big that the mass of their stars varies from 0.1 billion to 5 billion suns. Our frameworks in the universe say that such extensive, well-formed galaxies shouldn't have been around in the early universe. So what's going on here? Usually, a galaxy with any of these characteristics has a significant amount of dust, which would cause a lot of light reddening. Well, where really does all that dirt go? For this to make sense, we need a quick review. Cosmic dust, which is made up of tiny particles smaller than a few millimeters, is everywhere and has been an essential part of the history of every planet and star system. When molecular clouds, which are made up of dust and gas, collapse, they form stars and their protoplanetary disks. But they block visible light from cosmic objects beyond them from reaching us. This makes the universe look dark and out of reach. But there's something good about them. When we point our infrared telescopes at them, we can see how the dust changes the light from the trapped stars into light with longer wavelengths. So, when we look at objects far away, we have to think about their dust absorption, which is how other dust affects the overall spectrum of light arriving from them. Then, we know this for sure. We can also figure out how many stars are in that galaxy or how big it is. Now that we've gone over the basics again, let's talk about the blue monster that the James Webb Space Telescope found in the early universe. Scientists are trying to find out how they can be so big and have no dust on them at the same time. As we've already said, galaxies this well put together shouldn't have been around so early in the universe's history. Because of how big they are, there's no way that dust won't cover them up. Massive stars and supernovae make a lot of dust. This has been true since the first stars formed about 100 million years after the Big Bang, but only when there was already dust around. The second generation of stars established much more rapidly and easily. which says that there must be a massive amount of cosmic dust slightly earlier on. However, these blue monsters don't. So where did all the dust go? Researchers came up with two ideas for how a bright, rich galaxy could exist without a bunch of dust. Dust ejection was the first idea. For this theory to function, ejecting dust must be an excellent way to get rid of dust. That means the rate at which dust is thrown out must be greater than the amount at which dust is made. Even though the dust ejection is a good explanation for why the James Webb Space Telescope didn't see any dust in bright blue galaxies, scientists point out that some galaxies with high redshifts may not fulfill the physical requirements for dust expulsion and might instead drop into the dust accumulation regime. The second idea is that most of the UV light might come from the interstellar medium, while most of the infrared light comes from dust from gigantic molecular clouds. With this supposition, the researchers can anticipate a lower bound for the far infrared flux that would come from the dusty molecular clouds. Since these galaxies have a high redshift, their far redshift continuum emissions have moved to millimeter bands that can be seen for the high redshift galaxy Glass Z13. Both JWST and WFIRST saw this, and its far infrared flux has much less than the lower limit that had been anticipated. Experts theorize that this result fits better with dust ejection situation, where the galaxy would be less bright in the far infrared because there would be less dust. Using Webb, strange objects have been seen that could completely change how we think galaxies form and change over time. But researchers still need to learn more about what these blue monsters are. And until we know for sure, we'll have to stick to theories. What do you people think? Leave your thoughts below. If you find this video interesting or informative, I would appreciate a like, a comment, and a subscription. And if you enjoyed the video a lot, please consider sharing it on social networks. Bye friends, and I'll see you soon.